like how can we handle the problem of change management, specifically the around DevOps, so the software changes and rollouts and everything like that for Blue Yonder WMS system, and how can it work smoothly. So we will be talking about what our methodology is. So we have been doing this type of work for, so this first version of this vision is about 15 years old. So that's when we started with this vision of approaching the problem this way. And since then, it has been improved quite a bit. So it's a tested methodology of how we can do the Blue Yonder WMS changes and tracking them. So the first and foremost is that the problem of DevOps in general is not a new problem. So since wherever we have systems like Bugzilla, Jira, all of them are quite mature systems. Version control systems are also starting with, CFS, and even before that, SVN, GitHub, TFS. All of these are tested concepts. One of the curveballs we have with the Blue Yonder is that which oftentimes creates headaches for folks, is that in Blue Yonder, data is very important as well from the point of view of managing the software footprint. So generally speaking, when you have code which translates into DLLs, executables, or anything like that, reports, that is fairly easy to manage its deployment through the environments. You have to somehow just get that software into the next environment, and you can pretty much go with that. With the Blue Yonder, though, there are a lot of elements which are strictly data, which is rows in a table, and those need to be handled as with the same set of protocols as data, which is integrations are all data. DDAs, which is how some screens used to be made. This is all data. Page builder for new system is all data. Policies is all data. So all of that creates a unique problem where so much of your deployment headaches are not with code, for which traditional version control and issue track were biased by, but they are all data. Oftentimes what we see is that with Blue Yonder specifically, people end up considering data as a fundamentally different domain, which creates problems. So for example, if you have a particular Mocha component, fair universally, you can go to any Blue Yonder customer and you would see that the Mocha command would exist as it exists today, right? It's a cumulative view of what that command is. If I look at move inventory, create anything, I see what it is there right now. But with data, unfortunately, what people end up doing is that they create it incrementally, right? What they would say is that they would, for a specific policy, for example, I would see 20 files sitting there in a data directory where this is version 1, version 2, version 3, version 4, which creates a very difficult problem for change management, for seeing the history, everything like that becomes very difficult. And some of that stems from the fact that we have not invested in a tool. So if we just upfront, as we can assume an issue tracking system and version control system, some of those problems slightly become much easier to handle. So our methodology fundamentally in this regard is very fundamental, that we want to consider code and data abstractly as the same, as one and the same. So we do not want to create a very high level distinction that, hey, what am I changing? Am I changing code or am I changing data? So we want to fundamentally remove that distinction. So which means that a person is working on a specific change request, a change enhancement, whatever term we use, they're working on that. And we know full well that one particular enhancement may involve code, may involve integrations, may involve policies, may involve pages, and that is all fine. So one package that is created would involve all of them. So to implement that vision, what we do is that we create this custom screen, which is called issue assignment screen. And that is available on fat client and thin client. So what a person does is that they just simply create an entry for themselves. So it is still self-service. A person is completely independent in terms of how they are going to work on the change. So it all starts with one step before that would be that you should use something like Bugzilla, Jira, whatever, TFS. An issue gets created that, hey, Saad, you are going to work on this particular change, and the change is described this way and that way. So you have that number that, let's say I'm working on change 1 to 3, right? So then I come to this screen and I say Saad is working on change 1 to 3. So in the issue ID, I simply say 1 to 3. That's it. After that, I simply use the tools that are at my disposal to work on that change, which means that if I am working on code, I simply use Mocha client, go navigate to that object, modify it. If I'm working on integrations, I can go navigate to that integration and modify it. If I'm changing a policy, I do that. So I do all those changes using the tool set that is at my disposal. And then at the end, I simply say, I'm done. So all of that changes were being tracked as they were being made. And then when I say complete, it simply checks in all of those objects using our protocols that we have defined earlier, which means that for data, it would capture the that if it's a policy, that policy row, if it's a integration, that integration object, and it would create a file from it and check the cumulative view of that file at exists at that particular time into the version control system. So that then creates the foundation of how the next task can happen, which is creating the rollout and everything like that. So this is the step 0, which is trying to create this environment through which we can make the changes using the tools that are at our disposal. So in order to further realize that vision, we have to understand that certain objects are slightly different. So mload is a tool that Blue Yonder uses in order to process files. It's a pretty nice handy tool that it views the world as a CSV file, and it processes each row of the CSV file using Mocha scripts available. So we understand that there are two curveballs then. One is that sometimes we have to delete objects, right? How should those be handled? And second is integrations, which are really not CSV files. They are, slightly different types of files. And integrations have some mutual dependency as well, that you have to make sure that you add a header object before the child object. So how we handle the deletes is that we basically extend the same concept of mload, and we create a folder up front in load, unload, and user OSSI delete. And the idea is that even when objects are deleted, their primary key is captured, and then when you apply such a rollout, those objects would be deleted in the forward environments as well. So this whole concept can handle deletes as well, which sometimes becomes a problem, but we can handle it. And for integrations, what we do is that parallel to Bootstrap and Save2 only, we create a folder for integrations, and then we create a bunch of folders in there for every type of integrator object. So idea being that when we complete an issue and if it included integration, so we create smaller files. So if one algorithm got changed, it would be just that algorithm. If event got changed, it would be just that event. So it creates a smaller set of files and exports them into the right folder with a cumulative view, and then we check it in, and then the rollout can happen afterwards. So these are very essential problems, because currently you might see that many times integrations are deployed, especially where folks would create a very large set, like a full integrated data ball, and that's what we are getting moved into the next environment. And that is how certain problems start to happen, because it was such a big change, and some changes from the lower environments can get into the higher environments, which were not really intended to go there. Another problem is with this whole mload structure that is fairly common. It started happening, a few releases ago, that Blue Yonder started to use sequence numbers in their table structure. So for example, if you look at the location type table, many of those tables, if you just did a select from it, the primary key is a sequence number, which creates again a very difficult problem, that if you simply unloaded it and try to load into the next environment, that would create a fundamental problem, because that sequence may already exist in the next environment. So that is another problem that the way we address it is that all the CSV files we create as part of our framework, basically we do not export the sequence number, we always export the name with it. So we create a bunch of views, and then the final objects that you would see in your CSV files in the mload directory would be, first of all, they would be files based on the folder would be a view name so that the sequence can be maintained. So that header is before the child. And then within those files, you would not see the sequence number, you would see the actual name. And then the mload files end up calling the underlying component to create those objects rather than simply creating, which causes the problem of putting the wrong sequence number in the next environment. So these are the basic building blocks. So in order to make it happen, first we look at deletes, same as inserts in terms of mload data structure. We create a fundamental framework to handle integrations at a smaller unit, right, which is very important. And then we want to make sure that we, in the same when we handle data with sequence numbers, also with the same framework and same concept. So this is an example of what integration data would look like. So if you are familiar with how it is today, all you would have in your rollout is most likely, one big file called all integrated data, which is everything. Versus what you would see here is that in a specific directory, for example, for events, you would see small files like this, different events are stored there. And if you open one of them, you would just see that event and that event argument. Just that is the unit. So which means that if you change one event, all you would have in your rollout is that one event, and that is what is getting moved into the next environment. Another change that happened over the last few releases is that the whole solution of WMS has two major components. One is WMS, which is Mocha-based code, reports, labels, integrations, everything like that. And then there is refs, which has pages, menus, menu items, resource bundles. Resource bundles are specifically for when we make custom web screens. So our philosophy in this case is that there should be one version control repository and one rollout, which should cover both refs and Mocha-based code. Right? So that's a fundamental thing that even though they are deployed in two environments, we create their source code repository, rollout, all those protocols into one, which means again we are extended the same idea of mload further. So as you can see that this is our approach, that the tool that is available mload, we extend it further, and we say that even the refs objects are in the same mload framework. And in those cases, what we do is that the mload file creates the YAML file in the refs folder to load it. So again, we use the tool that is provided by Blue Yonder, which is YAML, but we manage it via mload. So we have a single rollout, single code repository, and everything like that for even refs. For messages, you are not seeing messages here in our structure, because there our general philosophy is that messages you would continue to maintain in a message catalog table, because again we have both sides of the equation to deal with. So you always maintain messages there. And whenever we deploy rollouts, we take every message that is customized. We know that by Blue Yonder by looking at their customization level, and we load them all into refs. So basically 100% of messages that are available in Blue Yonder that you customize, all of them would be available in refs. So that is the general overview, right? So we review code and data the same way. And in terms of data, there are two fundamental units. For integrator, we create objects at a smaller unit, each algorithm, each event output, so that when we deploy it is just that set. And for everything else, we use mload framework, and we have extended it here and there. So we say that deletes are also mload, and we say that sequences would be handled this way, and we say that refs can be handled in that framework as well. So then the next topic is that this is where we often see a problem, that the documentation around Blue Yonder uh, oftentimes becomes such that it is not very useful because we lose track of what versus why. So Blue Yonder itself, every Mocha command provides very sophisticated framework to document itself. So the documentation of what a command does right now belongs within that command. It does not belong in a separate Word document in some folder someplace, right? So we want to make sure that that story is within the command itself using all of the documentation tags. So it provides documentation tags for the, as you can see here, you know, documentation of the command itself. What is it doing now today? So it should be a cumulative view. What is it doing now? It provides input, output, see also which policies it references, why, which exceptions it raises, why. All of those tags are within it. So they belong right then and there. Why belongs in version control system, right? So that is where the why should be answered from. So for example, this is an actual example of an object that we have. It has evolved over time. And every time, if I want to see what it is doing right now and why it reached that way, I just right click on it and I see a story which is saying, well, this issue, then this issue, and then I can see differences between them, and I can see the issue ID and what was the reason, maybe who approved it, what business sectors wanted it. All of that story comes from these three uh, views, right? If there are certain documents that need to be attached, they would be attached to the Bugzilla or Jira or whatever tool you use. So that is where the documents can be referenced. But if I'm directly looking at, hey, I look at this component, it looks, there needs to be some, why are they doing something this way? I look at the version control of it. I see the differences. I say, oh, this was introduced on April 3rd, 2018. Okay, fair. I can easily find that out. Why? It was because of issue number 8845, and issue number 8845 would tell me that, why it happened that way. So that is very important. What we see many times is that the story, in order to find the story of an object, we have to look at a series of Word documents which are just sitting in a folder, and that becomes very difficult to add value to the overall process. But if we look at this way, then it becomes very easy to see what's going on and why. And then data should be no different. Again, this is the story of code. But if I'm looking at a specific, like the top row is describing an event, right? So this event changed same way. I can right click on it. It's a very small set. So looking at the version control history is fruitful. I see it was changed, on September 9th because of this issue. Originally, it was created for this issue. So what was the change between them? I can see that as well through version control. And I can answer the question of why it was changed and what was the background of it. Similarly, the lower the row is showing policy. So when we are exporting policy, we are exporting a specific policy. So one row for a file. And I can see that, okay, this particular policy was changed on this date for this reason. And again, we can get the full story. So there's no difference fundamentally between the story behind a code object and story behind behind data. So all of that is the same using the same tools that are available. And then uh, these screenshots are from SVN and Bugzilla, but we support Git as well. That's a popular tool, and Git works in totally in a cloud framework. So again, you would create a Git repository, and then we create a few hooks called webhooks into Git, and that is how everything comes together in a Git framework as well. So this whole story can be done with Git and Jira as well. And then with that all in place, creating a rollout becomes very easy. All you do is in Bugzilla, you would have a create rollout button, and you would simply say, these are the issues I want to create a rollout with. Or in a Jira world, you would go to another page and just say which Jira items I want, press create, and you have the rollout. And the rollout would include data and code for these objects. and that's pretty much it. So it's very fair, and this rollout would be predictable, reliable. We really never have to touch the rollout when it's created. We just create it and then hand it off to the deployment person. Another thing is that the person who's creating these rollouts does not have to know Blue Yonder at all. They don't have to be a developer. Similarly, the person who is deploying rollout doesn't have to have any of those roles. So this is a purely independent task through which they can create the rollout. It creates a something which is a URL, which can then be sent on to the next environment to download it and create it there. So that's basically, I quickly went over the whole Smart Eyes methodology. Uh, Overarching, we need to have an issue tracking system and a version control system. The leading tools, there's a free option of Bugzilla and SVN. There's an option of Jira and Git as well. Even in Bugzilla SVN scenario, if you want to go with a free option, then it could be all provided as a hosted solution by SmartIS as well. Or if you want to go with Git, Jira, then of course that solution can work. Git is a SaaS service, and then Jira could be available in any framework as well. And then generally speaking, the problem of managing changes should become much easier.